test and deploy pipeline. We'll see where DevOps fits in the software development cycle. We'll talk about what version control is exactly and what are the types of version control that are available. And we'll follow it up with a small demo. So starting off with DevOps, the what, the why, and the where. So what is DevOps and why do people care about DevOps? A quick answer to what is DevOps would be, it's a mindset. It's a set of practices that focuses on automation. The why DevOps, that's basically the answer is you get to deliver faster, you get to deliver more often, and you deliver with less work, which is in a way you're talking about waste. Now waste in software is say when you work, but it doesn't go anywhere. Now you would want to eliminate that because ultimately it slows you down. Here is a bunch of data about productivity of software developers. And look at how productive they are depending on if they had say one task, 2, 3, 4 or 5. Now if you look at the one task column, say you can see that they are 100% effective. There's no waste. On the opposite end, we've got 75% waste when they have 5 tasks. So that means that they're 5% efficient on each of the 5 tasks that has been assigned to them. It basically comes down to multitasking, or as you can say, trying to do a lot of things at once. Multitasking is horrible. It sneaks up on you and ultimately it's very expensive. Let's see if this is familiar to you. Say you've been assigned one task. Now that's reasonable. You go do this thing and it feels like that you don't have that much to do. So you're working on that one task, but then come a couple of bugs that you must look into. So that's another couple of bugs that you have to fix. Say something's weird in production. So you have to go take a look at that. Say you have to apply some patches on the server. Say the production environment. Say the QA environment. Say there's a problem in QA and they can't deploy it. Say there's a new version of the software and then you have to go look at it. Say you have to deploy a release. So you started off with just one task that you were supposed to do. And now there's a lot on your plate, a lot of other stuff that just kind of leaked in. DevOps is trying to get you to focus on those distractions so that you can eliminate them for higher productivity and say less waste. What you really want to do is you want to try and push towards the left as shown on the productivity waste diagram. So you want to go down from 5 simultaneous tasks down to just 1. So in DevOps, a good way to think about all of this is if it's repetitive, you automate it. If it's painful, you automate it. So whatever is automated now, it's that process's problem. It's no longer yours. On the development project, a huge percentage of time is taken up by tedious and disruptive work. Say integration, testing, deployment, and all of these are solved by automated build, automated test, and automated deploy. So what are the benefits of automation? Well, first thing is it eliminates the tedium. It helps you to release more often. Now most companies, they don't release very often. And the reason is that it's usually risky to do a release because it's painful, it's disruptive, there's a lot of things that can go wrong, and there's a lot of human effort associated with it. But if you've automated all of that stuff, it's not scary, it's not painful, it's not disruptive anymore. Run some automated processes. And now your build, test, and deploy, it just goes along fine. Now, another thing. So if you're going to release more often, that also means that there are faster bug fixes. Say a bug comes in or some sort of problem shows up in production. You've got this nice automated pipeline. You fix your bug, you run it through the pipeline, and boom, you fix the bug. With releasing more often, it lets you do smaller, frequent releases. So it's a lot easier to get feedback on one or two items than it is if you've got, say, hundreds of them lined up. If you do these smaller frequent releases, it also takes you a lot less time to respond to the feedback. Say, if your bosses or your stakeholders say something like, I don't like this work, you can easily go and change the release and go back to a previous code stack. Now, DevOps allows you to be wrong faster. And because you can turn around and do a release much more quickly, smaller, frequent releases with less stuff in it means you can take more risk with what you do. So to recap, DevOps decreases your time from, say, feedback to fix. If you've got that automated pipeline for build, test, and deploy, you probably can do a lot faster if it's automated. It also decreases the number of things that you have to worry about. So you don't have to worry about the integration so much. You don't have to worry about test. You don't have to worry about deployment because it's all automated now. So it lets you focus on your real job, which is probably to write software. Now you and your team getting those features out and ready to go. Now where does DevOps fit in the software development? So we would typically consider software development industry as in a mindset, say people sitting and writing down code. But that's just a narrow way of thinking what the software developers do. Because they don't just write code, they test the code, they come up with the ideas for the features, they do the deployments, they do everything that it takes to get that software delivered. Software that's written is interesting, but software that's delivered, now that's valuable. So if nobody can use your stuff, it's probably not capturing any value. Now delivered software means you're actually capturing some value from it. So it brings us to the concepts of Scrum and Agile. Now Scrum and Agile helped us to get better at getting ready to deliver the software. Say we have working software at the end of a sprint, but it's not actually someplace that it can be used yet. So what do we have to do? We have to rely on the IT ops people, and we hand off whatever we have developed on our scrums to the IT ops people. They put it on their servers, they put it in the data centers, and they are basically the ones that are responsible for delivering the software. So the whole process, it kind of looks like your Agile and Scrum gets us good at getting ready to deliver. Then there's this, say, a brick wall where we throw our working software over the wall, over to IT. Now IT is responsible for actually deploying that stuff onto the servers. Now what DevOps is trying to do, it's trying to bridge the divide. You combine dev with operations, and you are trying to eliminate the brick wall and you're trying to connect the two. Usually that's through the means of automation. And the idea here is that there's a constant flow from development into operations, so you don't have to have that disconnect in the middle. DevOps is a mindset plus a set of practices that focuses on automation. Moving on, we'll talk about what version control is exactly. Let's think about it in, say, 3 different ways. Say you're working by yourself, say you're working with a team, say you're working with multiple teams. Now, if you work by yourself, your life is really simple. All you're going to do is use version control to protect yourself from your own errors. You're just going to make sure that you don't do anything stupid and you don't lose the changes. So basically, you're just going to use version control to back up your code, and maybe you are interested in seeing how your code changed between the previous versions. Say you're working with a team. Now you've got all the same problems with working alone, but you also have version control for integration. Now integration basically means combining all of your work together into a usable software that you're going to ship. That integration stuff is getting more difficult because it's not just your changes, it's a bunch of other people's changes as well. So having something like version control to sort and take care of all of that stuff and referee things when the stuff gets difficult and when there's conflicts, it's a really good reason to use version control. Say you have multiple teams, more people, more the complications. Now your integrations are not just across you and a couple of other people, it's across a couple of different teams. They're probably working on multiple sub-products and sub-areas. And you're trying to bring all of that together, combine the work, and eventually ship everything out. Now, the integration, the version control, it gives you the core tools for actually going about and doing that integration. You also want to track and compare the history. You want to change who changed what in the code. And you want to see the differences between what we did before and what we have now. Well, version control does that for you. There are two types of version control that we'll be looking into. So, you've got the Team Foundation Server version control, the TFVC, and we've got Git. Now, the real difference between the two of them is basically on how they work. TFVC is a centralized version control, and Git, that's a distributed version control. Now in centralized version control, you need a network connection in order to do anything with the version control. So say you want to add, you want to edit, delete, check in, check out, branch, merge, any of these things. You really have to have a network connection to the Team Foundation server or whatever your centralized repository is. Whereas on the other hand, distributed version control pretty much doesn't need a network connection. You can do all of that, all those kinds of stuffs, the add, the delete, the edit, the branches, the merges, all of that offline. Now, why do we need the network connection? Well, ultimately, TFS knows exactly what it is on your machine at all times because you're telling it, here's what I did, and here's what I did. And it knows exactly what you've got, and it knows what the current state of your workspace is. Distributed version control, on the other hand, you can do all of your stuff that you want on your local machine, and the remote server has no idea what you have on your local machine and what you've done until you do something called a push. So suppose you have 25 check-ins on your local machine into Git and your remote repository. Your Team Foundation server will have no idea about those 25 check-ins until you have actually gone ahead and pushed the check-ins. Now, people might be asking, what is the better alternative? Should I use TFVC or should I use Git? And clearly there's no correct answer for this. It all depends on the preference and the needs. We'll be focusing on Git for the moment. So I'll be talking about the basics of Git. Now Git does everything offline. The adds, the edits, the check-ins, the references, the merges, the branches. You can do all of that stuff locally with no network connection. But then there's this concept of something called as a remote repository. So your local repository is your local machine. Your remote is going to be, in our case, the Team Foundation server. Now you and your co-workers are going to push to that remote repository, and that is how you will bring all of your stuff together. Now a basic working flow of Git would be, First off, you're going to clone the remote repository. You're going to do this one time. It's only going to happen the first time only. You clone the repository, you create a local copy of the repo on your machine. You're going to work locally. You're going to do all your adds, edits, deletes, whatever you do. And when you are ready, you are going to do something called a commit. Now, a commit is same as a check-in in TFVC. So you commit your changes to the Git repository. Now you're going to commit it locally. That's an important part, local versus remote. And you're going to go through this process as many times as you want. You make a change, you commit. Make a change, you commit. You keep on repeating this process. You can do all of that locally with no network connection required. But at some point of time, you will need to share your changes with the rest of your team. And that's when you're going to push your changes out to remote. So all the commits that you do, all those check-ins that you did locally, push is going to push them out to the remote repository. That makes the local commits visible to the remote server. And once the remote server has them, that means the other people on the team, the other people with access to the Git repo, can now see those changes. That's the basic working flow of Git. We'll move on to some demos to actually look into how the whole process works. So I'll just move on to my Team Foundation server. So in this demo, what we'll be doing is we will start off with creating a new project. We will do the initial setup of the Git repo in TFS. Then we'll quickly hop into Visual Studio. We'll add some code. We'll make some changes in Visual Studio. We will commit the changes to Git, and we'll push them out to the Team Foundation server. So here, what we are going to do is we are going to create a new project. I already have a project in place, but I'll go through the process nonetheless. So you click on the new project icon over here, and it asks you for a project name, a brief description of the project, the version control, and the work item process. Now in our case, I have named my project to be dev_ops. I've selected the version control to be Git, and I've selected the work item process to be Scrum. If I go back and if I show you the contents of dev_ops, the code header basically contains the Git repo. So it shows you all the contents in the file. Currently the Git repo is empty. You can see two files. So one is the git ignore and one is the readme. Now we have to add a git ignore file for whatever kind of project that we do inside the repo. And that's basically, it tells Git to not pay attention to the bin, the object, the exes, the DLLs. It's going to understand the structure of our projects that are in Visual Studio, and it's going to tell Visual Studio to not include the stuff that shouldn't be there. Now, quickly moving on, hopping into Visual Studio. So what I'm going to do is I'm going to go into Team Explorer, which you can see in the rightmost blade. So there are three: notification, solution, and team. I'm going to click on the Team Explorer. This is the home page of the Team Explorer. You can see this small connector icon. That's the manage connections. So that is what I click. You can see a bunch of Git repos. You click on the manage connections, say connect to a project, takes me to my hosted repositories, gives me a whole list. I've already connected to the DevOps. And once you select it and once you say you connect, for the first time, it will ask you whether you want to clone the Git repo to your local machine. That's a mandatory step that needs to be done. Since I'm already connected, I'll go into my Team Explorer. Say, you can see the git ignore and the readme in the Solution Explorer. These are the contents of the DevOps repository. go to Team Explorer. What I'm going to do is I'm going to create a simple Hello World console program. So I go to Solutions, I say New Solution. I name my application as say Hello _World, and it's a C# console app. And I uncheck this box, which is a create a new Git repository, because I've already connected to the Git repo. And I'm going to say OK. Visual Studio is going to take a few seconds just to build it all up. So here is basically my program.cs file. If you go to your Solutions Explorer, you see these small pluses, which basically mean that all of these files are queued to be added to our Git repository. I'll just go to Team Explorer. I'll go to Changes, and I can see the changes down here. All the new program files which were added by Visual Studio, they're listed down here. Say if I want to commit, if I want to push it out to my local, I have to enter a mandatory commit message, say something like implemented the solution or created a new solution. And I press commit all. It says commit created locally. Now what I'm going to do is I'm going to actually write the program, add a couple of console lines to the program actually. So if I say console.writeLine, hello world, the most basic kind of program. And since I want to give control to the, I don't want it to close on my own, on its own, I've given a read line as well. And say I add a comment. Hello world program. See, I save it. So I go to my changes.
Aman, you need to share your screen.
Oh, did it get disconnected?
Yes, it did.
Oh, okay. Sorry for the disruption. It's getting bad. Can everyone see my screen now?
Yeah, it's loading. Aman should be visible.
Okay. Yeah.
Yes, we can see your screen.
Okay, so before cutting off, so I wrote this basic Hello World program in Visual Studio, and now what we are going to do is, say we are gonna go to Solution Explorer, click on the solution, right click over here, and we're gonna say commit. What this is going to do is, we have to enter a commit message. We're going to push this code out onto our local as well. Say implemented the world and commit all. Now what you can see in Team Explorer, let's go to the home, let's go to the changes. Sorry, let's go to the sync. And you can see the outgoing commits. Now these are on my local, and when I click on the push button, what it does is it pushes all of my commits, the outgoing commits, onto the remote repository, which is the Team Foundation server. Now there are two ways for actually pushing. One is just clicking on push, and the other is clicking on sync. Now how sync differs is basically it's a two-way process. So first it pushes, and then it follows it up with a get latest. So a sync actually gets the latest iteration of the code onto your local. What I'm going to do is go for a standard push. It says pushing it out to the current branch. Successfully pushed to the master. Now if we go back to our Team Foundation server and refresh the page, we can see that the hello world, what we have, program, that's actually program.cs, that has been pushed to the team foundation server. If it can be the other way around as well. So if I say I edit it over here and I add, say, this is another comment, added another comment, and say I commit it, I have to give a comment here as well. And I can commit it. Now what I can do is I can go back to Visual Studio. It doesn't contain, as you can see on the left hand side, the latest code. So what I do is I pull from the Team Foundation server. So if I click on pull, it will pull the changes, and here you can see it. The line, it was added. So that's how version control and Visual Studio and Git all function with each other in the small demo that I've demonstrated. I know this is just an elementary introduction. If you have any questions, we would be more than happy to address them right now.
Any questions at all? You could also type them in the chat window. All right, so looks like there are no questions from anyone. Any last questions? You could always type it in the chat window. Aman will be able to help.
Okay. Well, that was the end of my webinar and the demo. Thank you so much for attending. I will hand it over to Mekla.
Thanks, Aman. I request all the attendees if you could share your email addresses in the chat window. We will send you the recording of the session and also the deck. And also if you can share the city and state you are currently in, that will help us determine the best possible timings for our webinars. We are still trying to figure out the best timing. So please do share your information with us. We would appreciate that really. And talking about the Azure Everywhere assessment that you see on the screen, this Azure assessment is a Microsoft and our company Cloud9's joint investment. It is a consulting service that's available to your organization, and depending on your company, it may be free, or you can also use those hours to get a roadmap to one of the services mentioned on the screen, like Azure Migration, SQL Upgrade, BI and Analytics. So if you're interested, please email us at c9sales@cloud9infosystems.com, or you can call us at 855-225-6839. We will be happy to assist you. Thank you for joining us today. Our next webinar will be on March 28th, and we will send out communication soon regarding the topic for the next webinar. We look forward seeing you in our next webinar. Thank you for joining us, and I appreciate all the attendees who have shared your email addresses with us. Thank you so much. We will be sharing the presentation and deck with you probably by the end of this week. It should be out there. Thank you so much.